Hello. On this short early out day for my in-person students, I've planned a very short lesson for us about inscribed angles. So from our dictionary page, we had a definition of an inscribed angle. It's a beautiful circle. And it was an angle that had its vertex on the circle, meaning it's actually on the physical line, and its endpoints on the circle. So whenever you see something like this, we're working with an inscribed angle. Now let's just say this right here is 120 degrees. I'm just making this up. We're actually going to find a very interesting relationship to the inscribed angle. If we remember, the central angle for the circle is going to be the same as the arc measure. So if this is 120, this angle here is also 120. But that is no longer the case for this one. I can see physically that it has gotten smaller in angle. It's kind of like if you pull back on a rubber band, it's going to get smaller. Let's see. I used to have a rubber band in my desk, but I think I gave it away. So I can't quite 100% demonstrate right now, but ooh, actually, we have masks. Ha ha ha. So think about where this angle is at right now. If I were to draw it, kind of just trace it as it is relaxed. Boom. It would be an angle like that. But if I stretch it back, we can see it's a much smaller angle. The degree measure has definitely gotten smaller. And that's kind of what's happening when you have an inscribed angle. The central angle may be here, but the inscribed angle has been stretched. So it's smaller than the original angle. But how much smaller, we may ask? Well, I've got this circle here I'm going to demonstrate with. This is a special ruler. It's a 45, 45, 90 right triangle. So here's the 90 degree. And then these are each perfectly 45 degrees. So that means if I use this corner, I can make a perfect 90-degree angle in my triangle. So this is going to be a central angle. I'm starting at the center and going to the end. And I'm going to call this angle A, B, C for clarity. So because I use that ruler, I know that this is 90 degrees, like literally 90 degrees, which also means arc AC is 90 degrees. So I'm going to write these out. We know that angle ABC equals 90 and arc AC equals 90. Because the arc and the angle are equal, we know that for the central angle. But what if I drew an inscribed angle that used these 2 points but had its point on the circle? So let me switch colors here. I'm going to use red. So now, starting from A, I'm going to go to this new point and create an inscribed angle. Maybe we call this point D. So that would make this angle ADC. Well, I can definitely tell it's smaller than 90. Again, it got stretched backwards. So my 90-degree angle is much larger than this one. Well, I did mention this is a 45, 45, 90 right triangle. And I chose it for a very specific reason. If we look, my 45-degree angle now perfectly fits. So we cracked the case. The inscribed angle of 45 degrees, well, what's the relationship between 90 and 45? Well, 90 divided by 2 is 45 degrees. So that means to get from a central angle to an inscribed angle, you just divide by 2. And of course, you can also multiply 45 by 2 to get 90. So it all depends on the direction you go. To go from the central angle, you cut it in half to get your inscribed. To go from your inscribed, you double it to get to your central angle. So I thought that was a neat little way to demonstrate this, showing very physically with measurements we're familiar with, how the inscribed angle is exactly half the measure of the central angle. And of course, this does not just work for the 90 degree. I could do any measurement I wanted. I could make a 45-degree angle, cut it in half, and it would be what, 22.5 degrees? I just don't have the means right now to demonstrate that. I would have to go pull out a protractor. Anyway, that's just a short explanation of inscribed angles. I'm going to make a cleaned up version of this to post along with our notes for today. All right, that's all I got. See you guys next time.